picture this. You're standing outside in Alaska. The air is crisp. It's biting at your cheeks. And all around you, there's this incredible, purposeful bustling going on.
Yeah, it's a very active scene.
Right. You see people meticulously checking weather patterns. They're reading the cloud formations, feeling the shifts in the wind. You see them cleaning and preparing tools with just absolute mechanical precision.
And you've got older community members pointing out these incredibly subtle seasonal signs to the teenagers, like the specific resonance the river ice makes when you strike it, or the exact hue of a berry patch that indicates its hit peak sugar content.
Wow, yeah. And over there, a group is processing a recent harvest. They're making sure not a single ounce of meat or bone is wasted. They're dividing it up and packing it to be shared with the elders and, families in the community who couldn't be out there themselves. It is this massive, intricate choreography of survival, community, and ecological management.
It really is. It's a highly complex scene, and it requires an immense amount of coordinated intelligence. I mean, what you were describing is the reality of subsistence in Alaska.
It's so much more than just gathering food.
Oh, absolutely. It is a living, breathing system. We are talking about an entire epistemological framework, a system of knowledge, highly refined skill, profound responsibility, and just intense community participation.
And that framework is exactly what our mission is for today's deep dive. We are exploring a fascinating piece of educational policy called Alaska Cultural Standard C1.
Right, C1.
Yeah. And this standard requires students to perform subsistence activities in ways that are appropriate to local cultural traditions. But, the hurdle we need to clear right away is the definition of the word subsistence. Because if a curriculum developer thinks that just means teaching kids how to cast a fishing line or, shoot a rifle, they are entirely missing the universe surrounding those acts.
Completely missing it. We have to completely dismantle the idea that subsistence is just collecting food or, some basic form of hunting and gathering. The harvest itself is really merely the visible peak of a massive hidden cycle of knowledge.
Okay, let's unpack this with an analogy. Thinking that subsistence is just that one dramatic moment of catching a fish. That is like thinking a marathon is just the exact moment a runner crosses the finish line.
Oh, I like that.
Right. Because if you only look at that final 5 seconds, you completely ignore the 18 months of prior training. The biomechanical adjustments, the strict nutritional science, the mental preparation, the recovery protocols, and the coaches who guided the whole process. You just cannot understand the finish line without understanding the underlying system that produced it.
That is the perfect way to look at it. If we examine the connected elements that make a single harvest possible, the scope of the required knowledge is just staggering.
Where does it start usually?
Well, it begins with intense, calculated seasonal observation. We are talking about tracking multi-generational phenology, the precise timing of biological events, like tracking shifts in bird migration routes or calculating the exact thermal dynamics of ice breakups year over year.
Wow.
Yeah, and then there is the deep biological knowledge of species habitat and behavior, which is followed by the actual material engineering that goes into safe tool preparation.
And the cycle doesn't even end when the animal is caught or the plant is gathered.
Yeah.
That is really just the midpoint.
Correct. Yeah. After the harvest comes the complex chemistry of processing and preservation. You are dealing with thermodynamics and biochemistry, fermentation, salt curing, smoking to control bacterial growth.
Wow.
And then there's the strict mandate to reduce waste, the complex logistics of sharing and community distribution, taking care of the equipment, and the intergenerational teaching required to keep the system functioning. All of this is wrapped in a core philosophy of responsibility. Responsibility to the land, the water, the animals, and the community.
I want to dig into that responsibility aspect, actually, particularly regarding the animals, because the sources outline a perspective that, frankly, completely reframes resource management.
It really does.
Yeah, in the Yupik worldview, for example, animals aren't viewed as passive, mindless resources just waiting to be extracted. They're recognized as conscious entities.
Exactly. They are viewed as conscious beings that willingly give themselves to respectful hunters. And this is a fundamental paradigm shift from the Western model of resource extraction, which, often views nature as capital.
Right, just a commodity.
Exactly. But in this indigenous worldview, because the animal offered itself, the human incurs a strict, binding, ethical obligation in return. So proper treatment of the animal, utilizing every single physical part to eliminate waste, and sharing the harvest, Those are absolute requirements.
And there's an ecological logic to that, right?
Absolutely. The logic is that if you honor the animal and the ecosystem, the animal's spirit returns in the future to sustain the people again. It is an unbroken cycle of reciprocity designed to prevent overharvesting.
Which is fascinating because it reframes spiritual belief as an ancient, highly effective framework for sustainable yield. I mean, these deeply held philosophical values, they directly translate into sophisticated scientific practices and environmental engineering. Traditional ecological knowledge, or tech, it isn't just folklore. It is a living, systematic, and empirical body of independent science.
It absolutely is. And let's look at a prime example from the sources. The Yupik harvesting of alec, commonly referred to as mouse food or sedge roots.
Okay.
Gatherers interact directly with the winter caches of tundra voles to obtain these highly nutritious roots.
Now wait, I'm struggling a bit with the leap from leaving a piece of dried fish for a vole to rigorous STEM education.
Yeah.
Like if I'm a middle school science teacher looking at standard C1, how do I grade a student on leaving a symbolic gift? Where is the empirical data collection in that specific act?
Well, it is a fair question. The rigor lies in the biological mechanism and the ecological math behind the practice. The gatherers aren't just blindly digging up roots, they are timing the harvest for late autumn. Specifically when the sedge roots have reached their absolute peak nutritional density in starches, but just before the ground freezes solid.
Oh, I see.
And more importantly, they are instructed to take only a carefully calculated portion of the roots from the vole's cache. They are actively ensuring the vole population still has enough caloric energy to survive the harsh winter. So the symbolic gift of seeds or dried fish isn't just poetry.
It's actual biomass.
Exactly. It is a physical replacement of biomass. It is a systematic practice of maintaining ecosystem resilience, ensuring the voles survive to aerate the soil and cache roots again the following year.
Okay, wow. So the reciprocity is actually a mechanism for population control and agricultural maintenance. But let's push this further into the realm of hard engineering. Give me an example of traditional design that rivals modern infrastructure.
Oh, look at the Tlingit salmon weirs in southeast Alaska. For thousands of years, the Tlingit people engineered and constructed these complex wooden tripods across rushing rivers to harvest salmon.
Okay.
But when early colonial managers arrived, they looked at these structures with a really simplistic harvest-only mindset. They assumed these weirs were just crude dams blocking the rivers and destroying the fish populations, so they legally banned them.
Wait, they just banned them outright. They completely misunderstood the hydrodynamics and the biology of the technology?
Exactly. What they failed to realize was that the indigenous design was a highly advanced selective harvest tool. The engineering of the weir had to withstand the immense physical force of a rushing river, sure, but the spacing of the wooden staves was the true genius. Well, it wasn't random. The gaps between the staves were deliberately measured and engineered to let smaller, genetically distinct fish and non-target species pass right through the structure to swim upstream and spawn. It only temporarily detained the larger adults. It was a perfectly calibrated system for sustainable management that actively protected the genetic diversity of the salmon run.
The irony there is just incredible because if you look at modern agencies today, like the Alaska Department of Fish and Game, they use what they call resistance board counting weirs. And those modern weirs rely on that exact same indigenous logic.
Yep, the exact same.
They use highly specific picket spacing, often 1-inch gaps, to protect the run while allowing for accurate biological counting. The modern high-tech PVC and solar-powered weirs are quite literally just an iteration of ancient Tlingit engineering.
The mechanism is identical. And what's fascinating here is the sheer scale of the data collection involved in developing these traditional practices. Because, Western scientific studies frequently operate on a 3-year grant cycle. A university team observes a local ecosystem for 36 months, runs their statistical models, and tries to draw permanent conclusions.
Right, which is a tiny window.
Exactly. Traditional ecological knowledge operates on a multi-generational timescale. We are talking about continuous, unbroken observational records spanning centuries.
That fundamentally changes the definition of a data set. I mean, if you have been tracking the exact timeline of the ice breakup on the same river for 300 years through meticulously maintained oral histories, you aren't just tracking the fish. You're tracking the erosion of the banks, the subtle shifts in water temperature, the decadal climate cycles. Your data set is exponentially more robust than a 3-year snapshot.
It allows indigenous communities to detect long-term, low-frequency ecological patterns and subtle fluctuations that a short-term scientific study will just completely miss.
Which brings up a critical point for you, the listener. If you are listening to this on your commute or, at your desk, think about how you categorize nature versus the economy. We tend to put them in two entirely separate boxes.
Right. Nature is the woods, the economy is the bank.
Exactly. And that division creates this pervasive myth that traditional knowledge is a museum diorama. People assume subsistence is this quaint, antiquated relic frozen in the past, entirely separate from the modern world.
The frozen past myth is incredibly common, and it really undermines the reality of how these communities actually operate. Indigenous knowledge is dynamic, and subsistence is a highly active mixed cash subsistence economy.
Yeah, subsistence integrates directly with modern capitalism. People are earning cash from seasonal jobs. Maybe they're commercial fishing, working at the local clinic, or teaching at the school, and they are actively reinvesting that cash back into modern harvesting tools.
Right, like snow machines.
Exactly. The aluminum boat bought with cash, the high-powered rifle, the snow machine, the gasoline. These are the modern tools sustaining the ancient ecological practice.
The culture constantly adapts. It incorporates new technologies to increase efficiency, safety, and range, while still adhering to those core underlying values of respect and community obligation.
But here's the causal link that makes Cultural Standard C1 so vital. Because communities are using high-powered rifles and motorized boats, the physical efficiency of the harvest goes way up. That means the traditional laws governing how much to take become even more critical to prevent overharvesting. You need intense local regulation. And that is why the standard explicitly states students must perform activities in ways appropriate to local cultural traditions.
That word local is the absolute crux of the standard. There is no such thing as a single, universal, Pan-Alaskan native culture. The practices, the linguistic dialects, the physical tools, and the ecological realities vary wildly. They vary by place, by family, by community, and by the specific species being harvested.
Right, taking a coastal Tlingit salmon lesson and dropping it into an interior Athabascan classroom isn't just culturally confusing, it's ecologically useless. It's like teaching a kid in the Sahara Desert how to build an igloo to survive. The engineering principles rely on materials, thermodynamics, and environments that simply do not exist in their bioregion.
Precisely. Every distinct group has developed specific linguistic structures, tool designs, and environmental management laws tailored to their exact bioregion. You just cannot standardize this knowledge across the state.
And because this knowledge is so hyperlocal and so deeply tied to specific families and tribes, there are strict legal and ethical rules about how it can be utilized in a public school classroom.
If we connect this to the bigger picture, we're dealing with intellectual property and data sovereignty here. Schools, teachers, and curriculum developers are not automatically entitled to this protected knowledge just because it exists.
Which is a mistake a lot of institutions make.
Absolutely. Historically, there has been a massive amount of academic extraction. Outside researchers or institutions coming in, documenting indigenous knowledge, and publishing it without giving credit, compensation, or control back to the community.
So let's explain the mechanics of how we prevent that extraction today. The sources outline very clear boundaries. If a school wants to integrate this knowledge, they need free, prior, and informed consent, or FPIC. What does that actually look like on the ground?
Well, it means formal consultation. It means working directly with local tribal leadership and elders before a single lesson plan is even drafted. If a school is bringing in an elder or a cultural expert to teach, say, the physics of a specific tool, that person must be appropriately compensated for their time and their specialized expertise, exactly as a university would pay a visiting guest lecturer.
It also means protecting the raw data. If students are mapping traditional harvest areas, the school must ensure that sensitive information like the exact GPS coordinates of a family's traditional berry patch or a specific medicinal plant is never published or mapped publicly without explicit community authorization.
Because if you publish that map, outsiders will come in and over-harvest the resource, destroying the local food supply. The ultimate goal here is collaborative co-management of education, not data extraction.
So what does this all mean for the learner? If this knowledge is highly localized, fiercely protected, and requires intense consultation, how do middle and high school students actively participate? Like, what does it practically look like for an 8th grader to perform subsistence activities in a modern science class without it just being a field trip?
It requires moving far beyond passive observation. Standard C1 makes it clear that just watching a single demonstration, like sitting in a gym and watching a video of someone cleaning a fish, does not equate to cultural competence. Meaningful participation means the student takes on active, respectful, and mechanically involved roles.
The sources give us some brilliant examples of how you shift the educational model from just teaching about a culture to actively teaching through the culture. Let's look at the physics of fishing. Instead of just reading about leverage, drag, and fulcrums in a sterile textbook, students build traditional wooden jigging sticks.
And the physical mechanics involved there are complex. Under the guidance of a local expert, they source and carve local wood. In doing so, they are actively investigating how the structural design optimizes fishing efficiency.
Right.
They have to calculate how the specific modulus of elasticity of that local wood flexes differently than a modern fiberglass rod in freezing temperatures. They learn how the tool distributes weight, how the handle is ergonomically designed to be used with thick gloves, and how to manage friction and drag when pulling a line through an ice hole.
Wow.
Yeah, they are doing structural engineering, physics, and cultural participation all simultaneously.
Or they can dive into climate science. There is a documented example where students interview their family members to track historical harvest times for local berries. They take those multi-generational oral histories, that deep data set we talked about earlier, and they map those historical timelines against contemporary environmental observations and modern climate projection data.
That's a great example.
They are physically tracking how climate change is altering the phenology of the tundra berry harvest, which directly impacts their community's food sovereignty.
That is a perfect integration of traditional data and modern climate modeling. And, it is crucial to emphasize that student participation within this standard is highly adaptable. Not every student will, or even should, be the one actively hunting the animal or harvesting the plant.
Right, because we have to honor family choice, varying physical abilities, and, well, just different comfort levels.
Exactly. Active participation can mean engineering and maintaining the tools. It can mean recording the seasonal knowledge and managing the data. It can mean helping to biochemically process the food once it's brought in, or even managing the logistics of distributing those harvested resources to the elders.
It ensures every student has a respectful, active role in the system, even if they never touch a rifle or a fishing net. It shows students that science isn't just an abstract concept that happens in a laboratory somewhere. It is a vital, localized tool for community well-being. It is a way of fulfilling their obligations to the specific place they live.
Which perfectly aligns with the underlying philosophy we started with. When we synthesize all of these sources, the biology, the engineering, the data sovereignty, it all points to one central idea. Subsistence is not only about what people receive from the land or the water.
It is fundamentally about how people fulfill their obligations to the resource, to their community, and to the generations that will inherit that ecosystem after them. It is an intricate system of continuous relationship. It is the training, the diet, the coaching, the entire marathon, not just the finish line.
Exactly.
And that leaves me with a thought I want you, the listener, to mull over today. Imagine your typical week. Think about the mechanisms of your daily trips to the grocery store and the way our modern, highly industrialized global food systems are structured around maximum extraction.
Right.
Now imagine if all of that infrastructure was suddenly restructured around the indigenous principle of the honorable harvest. What if every single time we interacted with our environment to consume a resource, we were systemically required to leave a biological gift, to minimize our ecological harm, and to calculate our take based only on what the system could naturally regenerate? How would our entire relationship with the world outside our doors change overnight? Something to think about.